Imagine two students take the exact same test. They both work equally hard and answer the same number of questions correctly. But when the grades come back, one student receives full marks, while the other gets a much lower score. You wouldn't call that fair. It's like a football coach who always picks the same players for a match, even when others on the team are performing better. We expect humans to treat each other fairly, and we expect our technology to do the same. When an artificial intelligence wakes up and starts making decisions, it doesn't have human feelings. It doesn't hate anyone, and it doesn't pick favorites. Yet it can still make unfair judgments. This lopsided way of making a decision is what we mean when we talk about AI bias. It happens when a computer system starts showing unfair preferences, treating one group differently for no good reason. The AI isn't deciding to be mean. It actually doesn't invent knowledge on its own at all. It learns entirely from what we call training data. You can think of training data as a giant textbook of information that humans feed into the computer. If that textbook contains unfair patterns, the AI learns those exact patterns. It will blindly repeat them, completely unaware that it is making a mistake. Think about teaching a young child what an apple is, but you only ever show them red apples. If someone hands them a green apple the next day, the child will say it's not an apple. The child isn't trying to be wrong. They simply learned from an incomplete set of examples. AI systems learn in exactly the same way. If engineers build a face recognition system, but train it mostly on photographs of one specific group of people, the AI becomes very good at recognizing those specific faces. But when it tries to recognize anyone outside that group, it struggles. Or imagine building an AI to recognize animals. If you show it 500 pictures of dogs, but only 5 pictures of rabbits, it will likely look at a rabbit and label it a dog. It simply hasn't seen enough rabbits to know the difference. The same thing happens in a school library. If an AI is only trained on a list of adventure stories, it becomes entirely incapable of recommending a science textbook or a history biography. The AI is never purposefully leaving out rabbits, different faces, or history books. Its failures happen because humans gave it an incomplete education. Suppose a teacher asks a class to vote on their favorite fruit, but only surveys 5 students who happen to love mangoes. If the teacher announces that everyone in the class loves mangoes, the conclusion is false. The decision was based on a small, incomplete group. If the information used to teach the AI is missing pieces, out of balance, or years out of date, it stops reflecting the real world. This flawed information is biased data, and it is the root of the problem. If you train a bird-watching AI without pictures of owls, it won't see owls. If you train a weather AI only during the summer, it will fail to predict the winter snow. If a teacher writes a science exam using only Chapter 1, the students who studied the whole book are treated unfairly. This chart shows what unbalanced data looks like. We have 900 apples and only 10 oranges. The AI will favor apples every time. If we adjust this to include equal columns for apples, bananas, mangoes, and pears, we create balanced data. Now the AI has a fair chance to learn about every fruit equally. But balance alone isn't enough. The data must also be diverse. If an AI is going to work across the globe, it has to learn from a massive variety of examples, different languages, climates, and environments. The information must also be correct and current. If you train a navigation AI using 10-year-old maps, it will route drivers onto closed roads. If a human accidentally labels a picture of a cat as a dog, the AI learns the wrong pattern. Everything an AI knows comes directly from its data. The quality of its textbook dictates its ability to make smart, equitable choices. Today, AI works at a speed humans can't match, making quick decisions that keep our world moving, from managing records to guiding travelers through airports. When an airport uses a face recognition scanner trained on limited data, travelers from diverse backgrounds experience frustrating delays. The system forces them to try again and again, simply because it hasn't seen enough faces like theirs. In the wild, cameras tracking endangered species can completely misidentify a rare snow leopard because they've mostly seen lions and elephants. Even an AI translator, if trained entirely on casual text messages, will fail completely when asked to translate a legal document or a complex science lesson. Because these systems work so quickly and repeat their choices so often, one small error in the training data doesn't stay small. It can ripple out and affect thousands of people in a single day, which is why human beings must constantly monitor what the computer produces. We can make these systems fairer. The first two steps are collecting better, more diverse data. To recognize flowers, an AI must be fed lotuses, tulips, and orchids, not just roses. To recognize people, it needs examples of different ages, skin tones, and lighting conditions. Step 3 is careful testing. Before a self-driving car is allowed on the street, engineers can't just test it on quiet, sunny days. The AI must prove it can navigate fog, snow, and heavy rain at night. Step 4 is human review. For important actions, humans must always verify the AI's suggestions. Doctors, pilots, and judges review the computer's advice before any final action is taken. Steps 5 and 6 involve continuous improvement and feedback. When you watch a video online and click "Not interested," you are giving the AI feedback. It uses that signal to update its patterns and learn exactly where it made a mistake. Building fair AI is an ongoing cycle. We teach, we test, we listen to feedback, and we update. The system must constantly evolve to match the reality of a changing world. If a school gives every student a robot helper to carry books, and one student uses their robot to disturb the class, the robot isn't to blame. The problem is how the human chose to use the tool. To prevent tools from causing harm, we rely on AI ethics. This is the vital rulebook that ensures technology is designed to be fair, safe, honest, and responsible. Ethics demands fairness, meaning everyone gets an equal chance, just like the rules in a drawing competition. It also demands safety, ensuring a self-driving car will always prioritize the pedestrian crossing the street. It requires strict privacy, keeping home addresses and passwords completely secure. And it requires transparency. Just as you expect a teacher to explain how your test was graded, engineers must explain how an AI arrived at its decision. Finally, ethics emphasizes human responsibility. An educational AI might look at the data and see a student struggling with fractions, but only a human teacher looks at that same student and sees their effort, creativity, and rising confidence. The future of this technology relies entirely on teamwork. Engineers, doctors, teachers, and ethics experts are all working together right now. By checking the data and setting clear rules, they ensure this ultimate learner becomes a trustworthy assistant for everyone.